Okay, we're down to proving the last two algebraic identities associated with complex numbers in our list of 8. We're going to do 7 and 8. So 7 is proving that the real part of I times a complex number z is equal to the negative of the imaginary part of z. So let's show what that is. And just recall that z we can write as x plus iy, where x and I are real numbers. This is the standard form. So the real part of iz is the real part of I times x plus iy. And now let's distribute this, I times these. So I'm going to get the real part of, and I'm going to do this first. I'm going to do I times iy first. That would give me a negative 1 times y. Negative y plus ix. So now this is written in the proper form. Here's the real part, and the imaginary part is x. Well, what's the real? So the real part of this is simply negative y. Well, what is the imaginary part of z? It's y. But if we want the negative of it, we get negative y. This is negative the imaginary part of z. Okay, let's look at number 8. Number 8 is similar. I'm going to do some of the same work, but that's fine. It just takes a minute. The imaginary part of iz is the imaginary part of I times x plus iy. I didn't have to put the I in parentheses, but I did. That is equal to the imaginary part of, let's distribute the I through. And again, let me do I times iy first, which gives me a negative y plus ix. Well, here's the real part of this imaginary number, and x is the imaginary part, the part that's being multiplied by I. And sure enough, remember that z is x plus iy, and the real part of that, the real part of z is x.